Hello and welcome to Screencast 5. This one is about DB2 address-based CPU. So I'm going to take you through some data from a customer I know very well. We're going to talk about 4 ZOS systems in a parallel sysplex: sys-A, sys-B, sys-C and sys-D. Now, of course, they're not their real names, but I've done a good job of obfuscation, I think. And on those 4 systems, we have 2 DB2 data sharing groups, which we'll call D2P and D2W. And all the subsystems names begin D2P and D2W respectively. Each of those data sharing groups has a member on each ZOS system, so that's 4 members for each group. So I wrote some new code and captured a new hill, which I think is quite significant, and I'm going to take you through the next couple of screencast episodes or so, some of the results of that. So today I'm talking about DB2. So what it does is it produces CPU reports on the major DB2 address spaces on an hourly basis. And the 4 things I graph at present are TCB as a percent of an engine, SRB as a percent of an engine, zip on zip as a percent of an engine, and zip on GCP or overspill as a percent of an engine. Now, I mentioned SRB and I mentioned zip on GCP, but I don't intend to show you the graphs for those because they're both basically 0. So in this customer, as in every other customer I would expect, SRB time for the DB2 main address spaces is going to be minimal. And in this customer, but not necessarily in other customers, the zip on GCP time is minimal. So let's just look at 2 graphs. The first one is TCB time as a percent of an engine. And here we have a large number of address spaces which have got non-trivial amounts of TCB time, by time of day obviously. Now note, the major DB2 subsystem address spaces are the master, DBM1 and dist, and we have RLM that does lock management as well. Now dist is where the DDF work runs, and what I've done here is I've color-coded the 2 data sharing groups, dist address spaces and also DBM1 address spaces. So you can't see the individual subsystems by name necessarily, but you can see the gist across the group. So the orangey red ones are the D2B dists. Now their TCB time peaks in the day and is considerably above the DBM1s, as we shall see. And D2W dist TCB time is also well above, as we shall see. Now this is because they're carrying all the distributed workload, and a proportion of it, roughly speaking 40%, is going to be never zip eligible and is going to run on a general purpose engine under TCB. Now overnight, conversely, we actually see the master address spaces getting busier, and that's probably related to all the batch activity that's going on, probably logging, I would have said, amongst other things. So that's TCB time. Now, the economic question, which is of interest to a lot of people, is going to be, well, what about zip? Well, I'm using the same color coding here, and what we see, first of all, is the D2P dist CPU that runs on a zip is peaking during the day, but it actually tails off into the evening, and there's a little bit overnight as well. And equally, the D2W DB2 subsystems dist address spaces, their zip usage peaks during the day and actually dies off rather further overnight compared to D2P. But I think it's quite important to note there's a lot of D2P and D2W DBM1 CPU time that's actually zip eligible, and in this customer case runs on a zip. Now one of the things to note here is that it's actually what I call high stringency CPU, as in you really want to provision zip well towards the DBM1 address spaces. One of the other things I should say is that a DB2 version 10, nominally about 80% of the DBM1 CPU is zip eligible. Now it actually widely varies, so I wouldn't take the 80% number as gospel. One thing I can say though is when you go to DB2 version 11 and still further on version 12, pretty much all the DBM1 CPU becomes zip eligible. In fact, this customer happens to be a DB2 version 11 customer, which is why the proportions of CPU for DBM1s are so low, as you saw on the previous slide, while the proportion of zip eligible and in fact running on a zip CPU is so high as here. So this is just a very quick look at how we see CPU across DB2 address spaces by time of day from SMF30.